So this is the analysis of variance table for this experiment. So we've got a source of variation, the degrees of freedom, and generally it would also have the sums of squares, and sums of squares divided by degrees of freedom gives us the mean square. So the first source of variation is the total variation. So there are, and I'm presenting the analysis of variance only for 1 year for the treatment that had only 2 fungicide treatments, but it's 5 varieties in the experiment times 2 fungicide treatments times 3 blocks. It's 30 entries minus 1 gives us the total degrees of 29 degrees of freedom. There are 3 blocks, so 3 minus 1 is 2 degrees of freedom for the complete blocks. The varieties, there are 5 varieties. 5 minus 1 is 4 degrees of freedom. Blocks times varieties, 2 blocks, 2 degrees of freedom for blocks, and 4 degrees of freedom for varieties, so 8 total degrees of freedom. The subunit is the fungicide treatment. There are 2 fungicide treatments in 2013. 2 minus 1 is only 1 degree of freedom for that comparison. Variety by fungicide, there are 4 degrees of freedom for variety, 1 degree of freedom for fungicide treatment, so 4 total degrees of freedom. Fungicide treatment by the blocks, that 2 degrees of freedom for that source of variation. And then varieties times fungicides times blocks give us 8 total degrees of freedom, and if you add them all up, the total degrees of freedom, all 29 of these are partitioned into 1, 2, 3, 4, 5, 6, 7 different sources of variation. So this test, this F-test of those 2 degrees of freedom versus those 8 degrees of freedom will tell us whether there is a significant block effect or not. That F-test, those 4 degrees of freedom versus those 8 degrees of freedom, will tell us whether there is a statistically significant difference among varieties that are under test over all levels of the fungicide. I think I can look at this source of variation and this source of variation and determine that this source likely will not be different from this source of variation, so I can pool those 2 degrees of freedom plus 10 degrees of freedom for a total of 8 degrees of freedom in the denominator to make a comparison or an F-test for fungicide treatments for the significance of fungicide treatments. So that's a total of 1 and 10 degrees of freedom in the F-test. This is the one that's most interesting. If my null hypothesis is what I'm interested in, this is what will give me an indication of whether there really is any interaction or any significant variation for fungicides, for varieties' response to fungicides with different levels of adult plant resistance. So that if there is a statistical interaction of varieties by fungicide treatments, then statistical interactions are due to one of 2 things in general. There are changes in rank for yield protection, or changes in magnitude of yield protection. So if one variety responds in this manner with no fungicide treatments, it will yield high here, but it will yield low over through the array of fungicide treatments that it's exposed to. And another variety will have a different response. This is the response we would expect. But if there is a statistically significant interaction in the change of rank, this is something like what we would expect to see. And this is what we would expect to see if there's a change in magnitude. So under a zero treatment effect, one variety will be ranked better than the other variety, but the magnitude of difference at a different treatment level will be much wider. So again, 2 ways to think about statistical interactions, changes in rank or changes in magnitude.